Shanghai GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Hi everyone, welcome to the Ryan and Michael Show. I'm Ryan Boyd.
And I'm Michael Manoochehri.
And we're here today to talk about preparing your data for BigQuery. So if you have any questions throughout this little discussion on preparing your data and loading your data into BigQuery, you can feel free to ask them in the Google moderator that is available on developers.google.com/live. Hopefully you're watching it there. And you can ask your questions, and we'll save some time for the end to answer them. Of course, if you have any other questions after today, or you're not watching it live, you can ask those questions on Stack Overflow, and we'll answer them there, or reach out to Michael or myself on our Google Plus handles that you see on this page. So looking forward to hearing from you. Now let's dive in. So the first thing we want to talk about is the data format. What does your data need to look like when you load your data into BigQuery? It's pretty simple. It's a CSV formatted file. So here we can see 3 lines of a CSV file. This is actually data representing Sorry, Michael, do you remember what this data was? Sorry, it's been a little bit.
Yeah, that's right. It looks like this might be election data or maybe natality data.
Yeah, exactly. So, but anyway, 3 rows of data in a CSV file, and we can see some of our basic types here. We have strings, we have ints, we have floats, and we have Boolean values. Mm-hmm. Those are the main types that you're used to using in BigQuery. And you just format a CSV file, new line delimited. You can quote your strings and things like that, but basic types. And our goal through the rest of the discussion here today is how to prepare these CSV files and get these into BigQuery. Now we have developers using a variety of different data sources. How you prepare your data and load it into BigQuery often really depends on your data source that you're using. So let's talk about the types of data sources that BigQuery users, our developers or customers, are using to load into BigQuery. It's all sort of transactional data. Mm-hmm. So the data sources commonly used to make sense in a BigQuery style database are transactional data, things where the append-only style of BigQuery works out well. So weblogs is one of the most popular. The standard Apache weblog, various fields, representing information about the user that's accessing the site, what page that they're accessing, the host, things like that. That type of data is fantastic for BigQuery. And those weblogs can be things that, are on your own local web server in your local data center, or it can also be cloud-based weblogs, so App Engine logs or logs from other cloud-based platforms. So that's one of the most common, but then you might actually have some more specific types of log files for mobile or web application events. Mm-hmm. So for instance, on the Google Play Store, there are a number of applications there. One of the top applications on the Google Play Store actually uses BigQuery to run a lot of analysis. And I'm not sure what particular data they're running, but web application events and mobile application events is a really great type of data to load into BigQuery and analyze with BigQuery. And you can also often get lots of traffic on the initial day. You launch on the Play Store, and you can potentially get a lot of customers immediately, and you want to be able to track how they're using your product and be able to use that information to improve your application that you're offering. Syslog style data for machine performance. The range of different use cases that developers use BigQuery for is very diverse. So we have people using it for ad monetization, but also people using it to monitor their servers. And that's what this one is about. Syslog style data, monitoring machine performance. We actually have a case study that should be out soon that really talks about how one of our developers uses it to monitor the performance of their applications and the machines that are hosting those applications. Then, of course, we're Google, advertising, click, and impression data, sales transaction records, all very important types of transactional data that is great to load into BigQuery for analysis. And the last one I mentioned here is App Engine Data Store. So oftentimes you may have sensors in machines all around the world, and you want to load that data into BigQuery. It's best to use the cloud to really collect that data, and App Engine is a great way to do that. So you can collect the data in App Engine, put it into the data store, and then take the data out of the data store and load it into BigQuery in batches. And we'll talk about how we've used some of our Google technologies for doing that here shortly. So now I want to talk about the process of loading data into BigQuery. The process of loading data is pretty simple. Your data is loaded by preparing your data, uploading it to Google Cloud Storage, and then uploading, or from Cloud Storage, you're basically making an API call to BigQuery and telling it to ingest the data from Cloud Storage. It's a fairly simple process. I will say that you can technically skip the middle part of this process here and upload your data directly to BigQuery. We generally don't recommend it because Cloud Storage is really optimized. All the APIs and tools around Cloud Storage are really optimized for handling large files. And so that's often the great way to do it. You get your large files into Cloud Storage, and then you let BigQuery retrieve them from Cloud Storage as part of its ingestion process. And that's the most, the least error-prone way of doing this. And so we've had developers try to upload their files directly to BigQuery, and sometimes they just run into some issues. And those issues are usually because they're uploading very large files, and they're trying to make a plain HTTP request to upload those large files, and not taking advantage of our resumable upload feature that we have. And the resumable upload feature, if you're using the resumable upload feature, I think you should be able to get about the same reliability, even if you skip Cloud Storage in this process, uploading directly to BigQuery. Try it out, let us know what you're seeing, and we'd be happy to know if there's great success in using that resumable upload to upload directly to BigQuery. Our libraries support this in a lot of the libraries. Support the ability to do resumable uploads. We don't yet have it super well documented on the BigQuery side. We're working on that, but you can see the generic library documentation on how to do resumable uploads. Now, the next thing we wanted to talk about, and I'm going to turn over to Michael for this, is chunking your data, breaking up your data into the parts required for ingesting it into BigQuery.
Yeah, so let's dive into it. So as you know, BigQuery is used for analyzing or asking questions about massive data sets. But to get your data into BigQuery, it's good to chunk it into parts. So BigQuery supports ingestion or loading of both compressed with a gzip or uncompressed files. Right now, the maximum size of each file is 4 gigabytes, but you can ingest large batches of files. You can ingest up to 500 files in one load job, as long as the total job is under 100 gigabytes. So anecdotally, I've run some tests using some of the data that we have internally, and I've been able to ingest upwards of 300 gigabytes of uncompressed data in one load job by first gzipping that data and then ingesting it into a single batch. So you can actually put in a lot of data in one batch ingestion. This is another advantage to using the cloud storage for ingesting. You can ingest giant batches that are stored in cloud storage. So it's really great. Let us deal with the infrastructure. I think that's usually a good lesson. And so let's talk about speeding up the data loading. So I just told you that you can ingest an enormous amount of data in one load job. There's other ways that you can even improve this ingestion rate. We actually let you ingest 2 concurrent ingestion jobs at a time. So you can have these huge batches, 2 of them in flight at a single time. And so you can do that, 2 concurrent, and we can also allow you to do 1,000 per day. So you can do the math. If you're ingesting hundreds of gigabytes of data, you can ingest thousands of these, or 1,000 of them a day. And so you can get a massive amount of data ingested into BigQuery in one go.
Now, some people try with that 1,000 per day to stream data in, and generally, BigQuery is not designed right now for streaming style ingestion. You can still upload and do many ingestion jobs per hour and have sort of near real time data. But you're not going to get down to the second data quite yet. If that's something you're interested in, yeah, definitely let us know.
Yeah, still a batch process. We'd love to hear it. Actually, Ryan touched on this earlier. Some people are using the data store to collect data, so that's a very highly available, performant way to collect data in real time, and then using a batch job from there to put the data into BigQuery. So there's other ways you can handle that. And
one thing I will say on the job style, we've been asked this question a number of times on Stack Overflow and other things, is whether when the job fails, if in some cases you have a misformatted line or something like that. If the job fails, does it ever partially complete? And the answer is no. When a job fails with BigQuery, that job is completely failed. We haven't updated your data at all, so you can just retry that job without ever having to worry about potential error conditions or anything along the way. And one other thing, actually, I should say that we've kind of forgot as we were preparing for this, but I think is really important, is at times, your data is not perfect. You're loading data in and it's not absolutely perfect. There's some formatting issues or what have you. You can actually specify kind of your error tolerance when you load data into BigQuery, either using the BigQ client or using the client libraries. When you create your job JSON object, you can basically say, I can have up to, say, 50 lines of data that are bad.
Yeah, misformatted or have bad encoding or something like that.
Yeah, exactly. So often you'll want to kind of do that as your first experimenting. You'll want to set a little bit higher threshold as your first experimenting. And as you get more and more data into BigQuery and you get confidence into your data format and your collection techniques, then you can actually change that and back off.
When you're dealing with huge file sizes, when you're dealing with terabyte file sizes or gigabyte file sizes, there's chances of having a bad line because of something that your output writer dealt with is it's high. So this is a great feature for that.
Yeah, exactly. So fantastic.
Cool. So let's talk about designing a BigQuery schema. So if you're from the relational database world, you're probably used to what we call normalization of data, which is to keep everything in one place and just have one copy of it. So in the example we have here, this is a relational database of two tables, one with parents and one with a person. So a person generally has two parents, and in this type of schema, the parents will have a key, like an ID, and basically all the data will be in one place. So your birth record will be in one place, and your parents will be a single record in a parents table, your father and mother. So this is a normalized table. So BigQuery likes to have denormalized data, non-relational data. So the idea will be to have a single a record with every bit of information flattened. So all the data that you saw on the other table will be flattened into a single record. So in practice, this means there can be redundancy and there can be null values, what we call sparsity. And this is the kind of table that BigQuery actually accepts. So when you have a relational data, what you want to do is flatten it out into a single record denormalized table for BigQuery.
And actually, I want to say, in terms of the advantages or the reasons you're taught in school to always normalize your data into the multiple tables that Michael just talked about here. One of the real advantages of that is just maintaining consistency of your data. So if you update information about a parent, in this case, that all their children see the same, parent metadata, the parent, change their age or something like that, all of the children records reflect that. And you never have inconsistent sources there. But, with a BigQuery style database where it's sort of an append-only transactional data, and you're really trying to do analysis, the consistency isn't a problem there, because you've had the consistency through the life cycle of the data as the data is being created, but then as you're analyzing it, the flat structure is much better for performance, and you don't lose any problems or lose anything by not having that consistency.
Right, that's great. So building off that, another technique for BigQuery is to actually shard your data. So by taking, say, in this example, we're taking birth records from different years and placing them into different tables. There's a lot of advantages to doing this. For example, BigQuery actually is priced by the amount of data you query. So by sharding your data, you can actually make your queries as efficiently priced as possible. This is also a good way to just make your queries more manageable, right? So you can say, I want to deal with data from 2011 and have the data sharded there. So this is a great way logically to organize your data into tables, into these kind of denormalized flattened tables that we talked about.
And of course, if you're trying to query, multiple years of data, you can just do simple union queries to do that.
Right. So we support that as well. Yeah. So great. So let's we talked to you a little bit about designing these tables and how to ingest data, but let's talk about tools for data preparation. What are the actual tools you can use to get the data into BigQuery?
Yeah, so there are a variety of different tools here, and it goes all over the board. It's a lot of it is based off of what your experience is. What your experience is, what the source of data is, where's the data is being collected, and things like that. What tools you're going to choose. But we'll give you an idea of some of the tools that we've used and some of the tools that our customers have used with BigQuery. So there's the App Engine, MapReduce, and Pipelines API. We're going to talk about this a little bit more later, but App Engine MapReduce is an implementation of the MapReduce algorithms in App Engine. It's a pure App Engine implementation, and we've used it, and we've heard others using it to great success in running sort of large jobs to transform data. And then, of course, the Pipelines API, which is actually what MapReduce is built in part on top of. And the Pipelines API basically allows you to create a dependency tree of jobs execution. So kind of a workflow of the various processes that are going into play. And again, running on App Engine. And it's very helpful for doing things where you want to process a bunch of files and then load it into BigQuery if the file is processed correctly. And we'll see an example here shortly. There are also, of course, commercial ETL tools. There's an entire industry out there preparing tools to allow you to prepare your data. And these tools are, there's a wide variety of them. The licensing and the way that they're structured is different. Some are actually even open source models. But I'm going to talk about Pervasive a little bit more. And then we also have Informatica and Talent, who have all integrated with BigQuery to allow it to be really easy for you to load your data into cloud storage and ingest it into BigQuery. And then, of course, our favorite, the Unix command line.
Rediscovered the Unix command line.
Yes, rediscovered the Unix command line. Oftentimes, there are simple Unix command line tools that you can use to prepare your data. This is especially great if it's a one-time load job that you're doing and not something you're regularly scheduling. These tools are pretty fantastic, and we'll give you some hints as to how we've used them. And then, of course, if you have XML, use a bit of code. We don't have too much on this in the rest of the presentation, but I will say, Wikipedia provides their revision history. So basically, all the revisions that have happened to every single page in Wikipedia, about 450 million rows, you can download that as one XML file. And if I'm recalling correctly, I think it was like 130 gigabytes compressed or something. Massive XML file. You're going to want to use a streaming-based parser or a SAX-based parser for that XML. And the LXML library in Python I found to be very helpful for doing that. So check that out. So on the commercial side, here's an example, is a screenshot from Pervasive's Rush Analyzer product, and we've worked with them to integrate BigQuery. And you can see in a very visual fashion and create this in a very visual fashion a workflow for loading your data into BigQuery. So in this case, they're actually taking data from a on-premise HFS, a Hadoop file system, and joining that data together with data from a MySQL database that's either in-house or in the cloud, and bringing that all together and joining it even with some, I believe, some FAT files, and selecting only particular fields after they do that join, selecting only the fields that they require, and then writing that out to BigQuery. And using cloud storage as kind of the intermediate step. But
I think these guys are doing that denormalization and flattening that we described earlier.
Yeah, exactly. That's actually all what this joining is the denormalization process of pre-joining the data before loading it into BigQuery. So it's a great tool for doing that type of thing, and you can do it in this visual style workflow. The other commercial ETL tools, the Informaticas and Talents provide similar style of creating your workflows. And I know with Pervasive, when you build that workflow, you can execute it locally, but you can also distribute the job to actually run it in, say, one of your local on-premise data centers, or even run it in the cloud and have this job really scale out to a lot of machines running this load job and schedule it and that sort of thing. It provides all that power and flexibility, but with this nice GUI front end to it. So that's pretty powerful, but sometimes you don't need that level of power, and that's where the Unix command line tools come in. Here's a row of data which I I do know where this row of data came from. This is the campaign finance data.
Yeah.
So this is the government actually publishes, the U.S. government publishes, donations to various political campaigns. So you can see here, this is a donation that I made in 2008 for $50. It's in that record. And it's all public data that the government's publishing. So one thing that you'll notice here that I've highlighted on this data is the year and the date. So 2008, 10/19 is when I made this donation, exactly 2 weeks after my birthday, apparently. I made this donation for $50. But the thing is, BigQuery doesn't handle date formats very well like this. I mentioned some of the basic date formats the basic field formats that BigQuery provides in its schema, and it's things like ints and strings and floats and booleans. Yeah, exactly. So these various formats, but dates currently don't have a special format in BigQuery. We rely on integers. And this is actually quite familiar with those Unix geeks out there, because time since epoch, or January 1st, 1970, is a very common way to keep track of time in Unix tools. And so we use that in BigQuery as well, and you can sort your data based off of that time since epoch. And it's really easy once you get your data in, but some people have a little bit of challenge doing the conversion to get the data in.
This is a very common data conversion issue.
Yeah,
so.
and something will probably resolve in the core product. And there are actually functions in BigQuery when you're querying the data to convert that time since epoch back out to a more human representative form.
Exactly.
But anyway, so here's our basic data. We have the time in 2008/10/19, and we want to convert it into a time that looks like this, which is that time since epoch. So that's the number of seconds since January 1st, 1970. And so to do that conversion is really, really simple on a command line tool. And I never would have known this without the web. Google is your friend when trying to do these things. I'm not that big of an expert in awk, but here is an awk command. Now you'll notice that I'm on my machine, logged onto my machine here, campaign finance directory, and what I'm doing at first is doing kind of a streaming unzip from gunzip, and piping that output to GNU's awk. And then basically what it's doing here is replacing the dashes in the date with spaces, and then passing that time as a string time into the mktime function to make a time object out of that. And that becomes our int, that's the time since epoch. And we're substituting column 10 of our original source file with that time and printing it all out. And then again, piping it out to gzip to compress the data again. So there's a really large source file. We can actually, only decompress a couple lines at a time, whatever's in the buffer here. So very powerful tool with just Unix command line. The other Unix command line tool that we should talk about that's pretty powerful is something to deal with that 4 gigabyte chunk that BigQuery allows for currently. So your file size on each file can be up to 4 gigabytes, and you sometimes want to split your source file into those 4 gigabyte chunks. And you can do that. Let's say you have a source file that's 12 gigabytes and you need this less than 4 gigabyte or less than or equal to chunk. You can use split, and this is how you do it. It's really simple. You're saying split -c, and -c is making sure that it doesn't split on anything other than a new line, so you don't get a partial line of data. But then it's writing out 4 gigs of data per chunk, and you have your source file here, and it will just create a series of other files which will be numbered based off of their position in that series with up to, in this case, it would be 3 separate files with 4 gigs.
And I use this command all the time. What's great about it is it's easy to script.
Yeah, so, exactly.
You script it and you put it into your ingestion job, and it's really great.
All right, now I'm going to head this back over to Michael to chat a little about a project that we've been working on recently to load 6 terabytes of data, or 2 terabytes compressed of data, into BigQuery.
Yeah, so like as Ryan said, we've been working on this really fun project. This is kind of putting everything we just talked about in practice. It's a study in loading 6 terabytes of data into BigQuery using App Engine. So this has been really great. We're looking at Wikipedia page views. So Wikipedia publishes hourly the page views of all the pages, and this is a huge, I think 2008 is the data that we're looking at.
Yeah, but it starts at the end of 2007, beginning of 2008. Exactly. I think we skipped the last couple of days of 2007.
Okay, right. So yeah, so we don't have all of it, but the data we have is 6 terabytes of data, and this is split up into thousands of files of, I think, hundreds of megabytes each. I think they're compressed. They're something like 100 megs.
Anywhere between 30. You can actually see from the size of the files how much Wikipedia has grown even since 2008, because the file sizes increased. I think from 30 megabytes compressed up to about 100. And I think there were like 60,000 files or something crazy like that.
It's an enormous amount of data, right? So what we're doing is using App Engine for the ability to distribute tasks across a lot of instances automatically. And so what we're actually doing, here's an example of what we're actually doing. The original schema of these Wikipedia page jumps looks something like this on the left side. So there's a language, the title of the Wikipedia page, the amount of page views is gotten in the particular hour that file pertains to, and the amount of bytes in the page, which is also great because you can see how that changes over time as well. So this is a really interesting data set. What we want to do is take this data, this raw data, and put it into a BigQuery table that looks like the schema on the right. So what we're doing is we're doing some of that sort of date-time transformation that Ryan talked about earlier, and we're breaking down year, month, and day to make our queries simpler.
On the date-time transformation, we don't actually show it here, but the files are actually named based off of the year, month, day, and hour of the request. So there's one file for every hour since the end of 2007. And so we're taking the info from the file name and actually combining that and joining that with the rest of the record.
Yes, exactly. And we're parsing that out and making the first five fields are based on that information. And also the Wikimedia project is actually something we pull from the title. That could be Wikipedia itself, and I think there's other Wikipedia projects that are not the main Wikipedia, but other things. So we put the language in there as well. We parse the title, and then we take the page views and the bytes transfer just as integers and put this into the table.
And actually, on the date time stuff, originally we actually put the date time literally as just a string, and it was actually quite easy to work with as a string if you knew some things about regular expressions. You could do the sorts and the searches and all with the strings. Because you were using the regular expression to convert it to integers and all for that process. But eventually you figured out not everyone, every time they run a query, even though regular expressions are super fast, even over hundreds of millions of rows of data with BigQuery, or billions of rows of data with BigQuery, not everyone wants to do that regular expression every time they're running the query. So that's why we did some kind of pre-analysis here and separated out, put the date time since epoch, and then the year, month, day, and hour, just to make it easier to query, even though it would have worked otherwise.
It's true. It's super convenient. Imagine running a query about noon. So give me all the pages that were looked at noon, and that's an easy query to do with this kind of format. One thing I forgot to mention is we're also sharding this data, as we mentioned earlier, into months. Right, so we have every bit of data is sharded into a table of a month. So we can look at the month itself, and if we want to look at more months, we can run a union query with BigQuery. We can even look at the entire data set month after month by just specifying the table name in our queries. So it makes it really convenient. I think this is a really good strategy for this type of data and this amount of data. But how did we get the data in? So that's the really interesting part. We decided to use App Engine and the Pipelines API, which we mentioned earlier. So what's great about pipelines, as Ryan mentioned, is it allows you to build a workflow and distribute the work of ingesting all of these files into multiple instances on App Engine pretty much automatically, and lets you just worry about the code itself rather than actually distributing this a bunch of cross task queues. So it's been really, really convenient.
Yeah, so I mean, on the distributed nature of it, it's been fantastic. So we're basically breaking this down by month and only processing a month at a time. And depending on the number of days in a given month, 720 to 740 sort of files for every month. And we're distributing that across, I believe in our latest configuration, about 100 App Engine instances, to have all of those 100 App Engine instances process this data simultaneously. And it just speeds this up to, what would have been a process that I probably would take like half a year on my desktop.
Right.
We can have App Engine do it in a much faster way.
The Pipelines API is great too because it provides a sort of control panel or status page actually of what's going on. So you can actually follow the workflow as it's happening and kind of check on the status of individual, let's say, leaves on the workflow tree and see what each one is doing. So it's been really convenient.
Yeah, you can see here the children kind of listed on the bottom right here. That's the children of this process month. And we can click on any of them. We actually did, you'll see some of these, I don't know if you can see it in the video, it might be a little too small, but some of these are calling pipelines called process file pipeline. That's actually doing the full transformation and processing the file. But some of the other pipelines are called return file name. That's in the case that we already processed the file and are just trying to make sure that it gets included in the upcoming ingestion job. So we kept track of the things that we were doing and stored that in the App Engine data store so that when we actually do, if we do have an error, if one of the files is bad or something like that, we can rerun this without any problems.
Yeah, and it's been great. The other thing is sometimes when you're dealing with this many files, like you may have a corrupted file in the source. There's all kinds of things that can happen. So adding this kind of sort of check on if you've processed the file is a really good best practice.
Yeah, so these basically just broke up by month, processed all the files in that given month, and then went off and called a BigQuery ingestion job. And our queues for, this is built on top of the task queues, our queues for calling BigQuery ingestion, basically we're configuring them such that we're only running the two ingestion jobs simultaneously on BigQuery to go by that quota limit. And we can, we're running those two simultaneously, but in the case sometimes that we mess up, we're actually detecting failures and rerunning the task in case there are any failures.
And Ryan, remind me, I think each month has something like 720 files.
Yeah,
so to ingest an entire month, we actually split that into two batches of, like 350 or something like that, of files to ingest them in multiple batches. So it's a great way to get most of that. We can almost ingest an entire month in one batch, which is pretty remarkable. It's quite a lot of data.
All right, so I think that's really about it for today's episode. You've seen Michael and Ryan's tips for how to work with BigQuery and getting your data into BigQuery, and hopefully this helps you a little bit as you load your own data. Let's give a quick overview of what we discussed today, and then we'll get into your questions that you have on the Google moderator. And so we've talked about denormalization being your friend, talked about sharding your data. If you need to transform your data, you can use a variety of different tools, commercial tools, App Engine, or your favorite Unix commands. And now it's time for your questions. Let's see what questions exist over on our Google moderator. And it actually looks like we have one person live on the Hangout as well. If the person that's live on the Hangout can introduce themselves and talk a little bit about what they're doing with BigQuery or what they'd like to do with BigQuery, and then feel free to ask any questions that you have. Hello, I believe you're muted right now. There we go. I think we're hearing you now.
All right. How's it going? Good to see you.
Great. Yes. So I'm the person in the Hangout then, and I'm not doing currently anything with big data. I'm fascinated by it. I'm working on with qualitative data for my PhD thesis, which is badly structured. Basically, you're doing text analysis, things like that, and I find it inspiring what can be done with processing and analysis of data. Now, the amount of data which I have, I could possibly process on any recent mobile phone, but there are in my other life, I'm working as a project manager in data center project management, and I find it intriguing to apply some principles which are used to analyze qualitative data with all the data that is available in all the files, logging, and whatever information you have in larger organizations. So it's some form of data mining, which escapes the typical data mining situation.
So BigQuery is really great for this kind of taking data out of silos, joining them, and then running aggregates. We actually have some customers doing this. This is a great use case because it handles such a huge amount of data. It's sometimes the only tool that can handle this in an ad hoc way to let you run these queries in an ad hoc way.
Yeah, we actually have a colleague of ours, Catherine. Michael and Catherine and I are all speaking at upcoming Strata conferences between London and New York, and Catherine's working on preparing her talk she's actually, I believe, keynoting at the Strata in London, and she's really looking at, from a data journalism perspective, how to source a bunch of data. A lot of the data, you're looking at a subset of data and trying to come up with a bigger meaning out of that subset of data, and you really, a lot of the work is really trying to find all the data that would possibly explain that small subset that you're looking at, and it's a lot of hard times, but hopefully some of the tips that we gave you here today will, at least once you can get your hands on that data, help you prepare it and kind of denormalize it and get it into BigQuery if you guys decide to do that.
This use case you brought up of text analysis is really interesting. We actually do some of that on our team as well. One thing to know about BigQuery is the maximum record size is 64K for any single record. However, it's great for things like n-gram analysis or word count analysis. So this is the kind of thing where maybe a MapReduce job to find, say, word counts per document and then put all of that data into BigQuery. That's a really good use of BigQuery, especially when you have tons of data.
Yeah, and we actually have some example data sets doing that already. They're like n-gram data set and then a Wikipedia data set. Yeah. I think the n-gram is from Google Books, I believe, and then not Wikipedia, n-gram.
And Shakespeare.
And Shakespeare,
right.
Yes. So we have some example data sets doing that. We're actually working with the Wikipedia stuff soon to basically take all of the text in Wikipedia and make that into n-grams, just to see, what words are most commonly appearing, when words first appear, and things like that. Some fun analysis on text data.
Yeah. One last thing is, the other thing that's really great about BigQuery is that it's an API and it's really easy to integrate into, say, web applications, any kind of application, actually. I mean, you ask questions, send queries to it via API. We also have tools. We have a browser tool and a command line tool, but you can actually write code with this very simply. So it's all kind of built in together with the API. So it makes application processing super easy. You can build JavaScript apps in just a few lines of code. You can use App Engine, and you can build a very powerful application in very little code. So it's great for some of the things you're talking about.
Where is the best place to get started? So I'm more a casual programmer, if at all. So I can do some stuff in Python or Java or processing to do little things, visualizations, but this is really old school, yes. So what I'm doing. So if I want to go into the big data examples or just fool around with it. Where do I start? Is there any place where you can get a step-by-step example to get you started?
On BigQuery, I think I would start out in BigQuery. I believe we have a step-by-step getting started guide working on some of the public data samples. Yeah. So the public data samples in BigQuery, you can actually run queries against up to 100 gigabytes a day worth of queries for free without putting down your credit card. So you can start by looking at some of that existing data and not deal with the process of loading your own data, but you can see what types of queries that you can perform. I've had a lot of fun looking at the natality data. For instance, that's U.S. birth statistics since 1969, I believe. And basically, there's a line for every single birth in the U.S. That's occurred in that time period. And you have some interesting things like in Ohio in 2003, if you look at the babies born there to mothers who smoked cigarettes versus didn't smoke cigarettes, the babies born to mothers who smoked cigarettes were half a pound lighter than the babies who had mothers that didn't smoke cigarettes. And you find interesting bits of data, and that's actually what BigQuery is really great for, is this ad hoc analysis in an aggregate fashion on large chunks of data. So I would try that out. Just play around with that data. In terms of visualization, you can actually see some of the demos from ClickView and Beam who have built visualizations already on top of that data set. And then use something like Google Apps Script. In about 70 lines of code, you can visualize data that comes from BigQuery queries in Google Apps Script inside a spreadsheet, and then do graphs and pivot tables and that sort of thing. And if you're a friend of Excel instead, we have the BigQuery connector for Excel that we just launched a week or two ago that provides similar functionality and is a really easy way to get this. So you don't really need coding experience right now. We're not. We aim ourselves as an API with BigQuery for developers, but to get started and trying it out, you don't actually need heavyweight coding experience. So on the BigQuery side, I would check some of that stuff out. AppEdge and MapReduce, I believe, has a getting started like word count sort of MapReduce that you can run. That's going to be a little bit heavier coding and a little bit heavier algorithms, understanding what's going on there. But hopefully, between those two data sources, so on BigQuery, just go to developers.google.com/BigQuery, and there's a getting started guide there, and try that out.
The one you mentioned, the browser tool. So we have the BigQuery browser tool. That's all through the web browser, and you can run some of these queries for free by signing up. Just go to the getting started guide on developers.google.com/BigQuery. Yep. That's the best place to get started.
Well, thank you for stopping by. It doesn't look like we actually have any other questions in the moderator currently, so I think the Ryan and Michael show is about ready to sign off. But thank you all for joining. It's been a pleasure, and hopefully we'll continue this. And let us know your feedback on Google+. Let us know your technical questions on Stack Overflow, and we're excited to keep on seeing how you're using BigQuery. Thanks.
All right. Bye, everyone.
Bye-bye.
Right.